Today we're going to look at section 5.3a. Our learning target is to solve polynomial equations by factoring. We have a lot of different factoring techniques that we're going to learn in this chapter, but we're also going to pull back some of the things we learned in chapter 4. In this section, we're going to look at 4 factoring methods that can be used to solve polynomial equations. Today's method is to factor a GCF out, and then we're left with a quadratic. Then we're going to solve that remaining quadratic by any method that works. There are several scenarios that can result to solve the remaining quadratic. For the first one, we're going to see where after we pull out the GCF, we have a quadratic that is still factorable. Okay, but remember, GCF is always done first. So looking at our first example, x cubed plus 22x plus 22x squared plus 21x equals 0. We're looking for a GCF that we can pull out. And in this one, we can take out an x. If we factor an x out of everything, we are left with x squared plus 22x plus 21. And then on the right side, we still have it equal to 0. And now that quadratic that we have left is still factorable. So we're going to keep going. We're factoring our x squared, splitting it up into x and x. To get a 21, when we multiply and have it add up to 22, we have a few options, 1 and 21 or 3 and 7. The one that adds up to 22 would be the 1 and 21. And now because we have it all in factored form and it's equal to 0 on the other side, we can take each of these factors and say, let's make that our 0. And then we have to solve those. The first one's already done, x equals 0. To solve the second one, we're going to subtract a 1. So we get x equals negative 1. And our third one, we're going to subtract the 21 to the other side. So x equals negative 21. So those would be the 3 zeros or roots of that polynomial equation. All right, our second example. We can pull out a 2 and an x. If we factor out both a 2 and an x, we are left with x squared minus 14x plus 45 equals 0. And now we're looking for two numbers that multiply to be 45 but add up to negative 14. We're going to split our x squared up. And we need numbers that multiply to be 45. We have 1 and 45. We have 3 and 15, we have 5 and 9, and to make the 45 positive, we either need 2 positives or 2 negatives, and since our middle term is negative, we're going to need 2 negatives. And then two numbers that add up to 14 would be the 5 and 9. And now we have it completely factored. We can set each factor equal to 0, so 2x could equal 0. Then I have to divide out the 2, but I'm still going to end up with x being 0. For this one, we're going to say x minus 5 could equal 0 and add the 5 over. So x equals 5. And here x minus 9 could be my 0. Add the 9 over, I get x equals 9. So my zeros or solutions would be 0, 5, and 9. All right, why don't you guys go ahead and pause the recording and try this next one. All right, let's see how you did. First thing I can do is pull out an x. That leaves me 2x squared minus x minus 10. And now I have to factor that quadratic. This one is a little more difficult because we have a 2x squared, but we're going to split that into 2x times x. And then I'm looking for numbers that multiply to be negative 10. I could do negative 1 and positive 10. I could do positive 1 and negative 10. I could do 2 and negative 5, or I could do negative 2 and positive 5. I'm trying to get it to add up to a negative 1x in the middle, and whatever I place here is going to get multiplied by that 2. So if I put a 2 here, that would create a 4x. A 5 here would be a 5x, and one of them has to be negative. If I make the 5 negative, I get negative 5x for the insides, and I get positive 4x on the outside. And that would add up to my negative 1x in the middle. All right, setting each of them equal to 0. I could have x be a 0. I could have 2x minus 5 be the 0. To solve that, I'd have to add the 5 over and then divide out the 2. And then for my last one, my x plus 2 could be the 0. And then subtract the 2 over, so x could be negative 2. All right, on our fourth example, notice that we don't have it equal to 0, and we have to have that. So that's my first step. I'm going to subtract the 63x to the other side. So now I have x cubed plus 2x squared minus 63x equaling 0. Once I have one side equal to 0, I can go ahead and use my factoring techniques. So I'm going to factor out a GCF of x. It leaves me x squared plus 2x minus 63. And then I can factor that quadratic, splitting up my x squared. I need two numbers that multiply to be negative 63 and add up to 2. So if I use a positive 9 and a negative 7, that would work. And then I have my solutions. X could be 0. X plus 9 could be 0, which means x would have to be negative 9. Or x minus 7 could be 0, which means x would have to equal a positive 7. So that's the first type, where we factor out a GCF and what we have left is nice and factorable. So we just keep factoring it all the way down and then set each factor equal to 0. The second thing that can happen is the resulting quadratic could be solved by square rooting. So again, we're still looking at taking out a GCF first. So on this one, I could pull out an x squared. It leaves me an x squared minus 49. Now for this one, we do have that x squared minus 49 is just a difference of squares. So we could continue and factor it, but we could also solve it using square roots. So I'll show you that method. We're going to have x squared being 0. When I square root that, I just get x equals plus minus 0, which is just 0. For the second part, I have x squared minus 49 could be 0. And to solve that, I'm going to add the 49 to the other side. And then I'm going to square root both sides. So I get x equals plus and minus the square root of 49. And the square root of 49 is 7, so I guess I could simplify that even further. We'll just say x equals plus minus 7. All right. Our second part here, we have 2x cubed plus 20x equals 0. We can factor out a 2x. That leaves me x squared plus 10. And then I can solve the second one by square rooting again. X squared plus 10 equals 0. So I'm going to subtract the 10 over. And then I'm going to square root both sides. And when I square root a negative, remember we have to pull that I piece out. So my answer would be x equals plus minus I root 10. And the 2x in the front could also be the 0. Dividing out a 2, I still get x being 0. So I have one real 0 at 0, and the other ones are imaginary, positive and negative I root 10. All right, the third thing that can happen is that the resulting quadratic can't be factored or square rooted. So that leaves using that quadratic formula as our method for solving it. So again, we need to have one side equal to 0, so I'm going to have to bring this one over. And because it's a cube, I'm actually going to put it right in between my 4th power and my 2nd powers, subtracting it over. So I'm going to have 3x to the 4th minus 6x cubed plus 12x squared, and now it equals 0. Okay, taking out our GCF, we could factor out a 3x squared. That leaves me an x squared minus 2x plus 4. Now the first one here, we have 3x squared. We set that equal to 0. Divide out the 3, we have x squared equaling 0. And then square rooting, we've got x equals plus minus the square root of 0, which is just 0. But this x squared minus 2x plus 4 is not factorable. There's not two numbers that multiply to be 4 and add up to negative 2. So we are going to have to do the quadratic formula on this. So we're going to have x equals the opposite of b, and b is negative 2, so I'm going to need a positive 2, plus minus the square root, b squared, so negative 2 is going to get squared, minus 4 times the a value, which is 1, times c, which is 4. And it's all divided by 2 times a, which is that 1. Simplifying, we have x equals 2 plus minus our whole big piece under our square root. We'll come back to that in a minute. And we're dividing it by 2 times 1, which is 2. So inside our square root, we have negative 2 being squared, which is 4. Then we're subtracting 4 times 1 times 4, so we're subtracting 16. So we have 2 plus minus the square root of negative 12 divided by 2. And we do want to break down that negative 12. So we're going to have 2 plus minus, the negative is going to come out as an I. The 12 we can think of as 4 times 3, and when we square root those, we get 2 root 3. So 2i root 3, all divided by a 2, which then we can simplify a little bit further and divide everything by a 2. So 2 divided by 2 would be 1, and 2i root 3 divided by 2 would be 1i root 3. So we have 1 plus minus I root 3. So I have an x equals 0, and I have two imaginary ones, 1 plus I root 3 and 1 minus I root 3. All right, so today you're going to work on worksheet 5.3a.